So, dear all, I hope you all are safe at your home. So, I am going to discuss a chopper. So, in the chopper, today I will discuss the following things. Number one, introduction of chopper. Second one is its application. Its application. Third one is duty cycle. Fourth one is switches. Fifth one is loads, and the last one is ideal step down chopper. So these are the following points which today I will discuss you in this lecture. This lecture is benefit for the student who are having who is studying the CD, that is the control of electrical drive and power electronics and drive, as per the GTU curriculum. Okay, so let's begin our number one, that is the introduction of chopper. So a chopper is a DC-DC converter, So in the DC-DC converter, we can say that if suppose that we have a fixed DC, and at the load side the requirement is, suppose that variable DC, means if we want 5 volt, 6 volt, 10 volt, according to that we will use this converter. So this converter is generally used to convert the fixed DC into variable DC. As you can see that fixed DC means, suppose that you are giving this 12 volt. From this 12 volt you are able to get 5 volt, 6 volt and 10 volt. How we will get, later on I will talk on this. Okay, so before I would like to go detail into the DC-DC converter, I would like to discuss the transformer. So in the case of the transformer, what we are doing, a transformer is generally at the input side we are applying this sinusoidal waveform, that is the Vm sin omega t, and the output we are getting as either step up or step down. So step up. So in the step up, what we are doing generally in the step up, if the input, means if the output is greater than the input, then we can say that it is a step up. As the name suggests that step up, so the output will be greater than the input voltage, then we can say that it is a step up transformer. Now another type of the transformer is what? Step down transformer. So in the step down transformer, the output voltage is less than the input voltage, then we can say that such types of transformer is called as a step down transformer. So same thing is happening in the case of chopper also. So if you have a chopper, if you are giving the fixed DC, so at the output what you will get? At the output you will get two types of output you will get, that is the step up chopper. Second one is a step down chopper. So In the step up chopper, if again, if V input is greater than V output, then we can say that it is a step down chopper. Step down chopper. And if V output is greater than the V input, then we can say that step up chopper. As we have seen in the case of transformer also, if the output voltage is greater than the input voltage, then we can say that step up transformer. And here we have also seen that the when V output is less than the V input, then we can say that this is a step down transformer. Same thing is happening in the case of chopper also. You are giving the fixed DC and at the end you are getting what? Step up or a step down DC. So now how we are going to get this fixed DC into the either in the step up chopper, means how we are going to get the fixed DC into variable DC. Okay, so let's change my page. Now suppose that before I am going into the detail of the DC-DC converter, I would like to discuss the application of chopper, where we are going to use this chopper. Because if you are studying anything, you must know the application of that, because where you are going to use such types of the thing. So number one is speed control of DC motor. Second one is SMPS. SMPS is just a switch mode power supply. Third one is battery operated car. Fourth one is battery charger. In all the cases, the main objective is what? Again, you are giving the fixed DC and at the end you are getting the desired DC as per your requirement. Okay, so now see, suppose that we have a DC source of 10 volt. Now after that we can convert this 10 volt into 5 volt by putting some resistance. If you will put a resistance, this is not an efficient system, because you are dropping it here. Because if suppose that there is a 10 volt is over here, now if at the end you are getting the 5 volt at the output, if you are getting the 5 volt at the output, what does it mean? There is definitely going to a drop over here. It is a passive element, so it will what? It will absorb a power. If it will absorb a power and it will dissipate a heat, so it is a passive element. So there will be definitely going to be a 5 volt drop over here. If there is a 5 volt drop over here, and if we will apply the KVL in this loop, so what we will get? Plus minus, so minus 10 volt plus 5 volt plus 5 volt. So there, this drop is what? This drop is across the resistance, but this is your requirement. This is the voltage which you are getting at the load. So we will not go into this approach, because this is not efficient. The efficiency is very low, because there is a loss is more, because as it is a passive element. So for that we are going into the we are using some power electronic switches. There is a difference between a manually operated switch and the power electronic switch. So if I am talking about the manually operated switch, manually operated switch means manually operated switch. If I am talking about the manually operated switch is whatever the switch which are used in the whatever the switch we are using at our home to turn on the fan or light system, that is the manually operated switch. But when I am talking about the power electronic switch, then it has a higher switching frequency. What does it mean? Means suppose that this is a switch and this is a power electronic switch. This is the power electronics switch and this is a manual switch. So in 1 second, suppose that in 1 second you can turn 1 time, 2 times, 3 times or 4 times. Okay, but in the case of the power electronic switch, these are the electronic switches, so in 1 second you can turn on or off 1000 times, 2000 times. So that's why we are calling it as a power electronic switches. So these are the very fast switches. So so we are not using the manual switches, we are going to use the power electronic switches in the DC-DC converter. Okay, so let's move on to the circuit diagram of the basic circuit diagram of DC-DC chopper. This is the 10 volt. Now if our requirement is 5 volt, here we are going to use a power electronic switch. This power electronic switch may be a MOSFET, maybe a IGBT, maybe GTO, maybe SCR. As we know that each has its own feature. Means what? Suppose that if we are talking about the MOSFET, and the IGBT, so MOSFET means what? MOSFET has higher switching frequency, but in the case of IGBT has what? It has a lower switching frequency, but one advantage is that it can handle high voltage as well as high current. But here in the case of MOSFET, low voltage and low current handling capability. So we can use either MOSFET, we can go for the IGBT, we can go for the GTO. GTO is a gate turn off thyristor. We can go for the SCR also, as per our requirement. What is the requirement, at what frequency we are going to operate that converter? According to that we are going to use that power electronic switch. And I have already discussed what is the power electronic switch, what is the difference between a manually operated switch and the power electronic switch. So now suppose that this switch is closed. If the switch is closed means what? The whole 10 volt will appear across this one. So whole 10 volt will appear across this one. So there is no conversion of 10 volt to the 5 volt, because if you will close the switch, what will happen? This switch will be closed. The same voltage, this voltage will come parallelly across this resistance or this load. If the load is resistive, then this voltage will appear across this load, and this 10 volt will appear across this one. So something we have to manipulate over here, how you are going to control this switch. If we are going to control this switch, we can control the duty cycle. Duty cycle means what? Suppose that at the input side there is a fixed DC, and we know that the fixed DC waveform is like this one. This is the with respect to t, there is a at any instant of the time, whether you're moving from the, when you are moving from the left to right, there is a no change in the magnitude. As the time progresses, there is a no change in the magnitude. So this is the waveform of pure DC. So now, if we are making it, the switch has a two possibility. A switch has a two possibility. Two possibility means what? Switch has two possibilities. One is turn on, T on. Second one is T off. So now when it is turned on, when this is turned on, this is T on. After that there is a T off. Again we are turning it on. Again we are turning it off. Again we are turning off. The same thing will repeat and repeat. So now, as we can see from the waveform, there is a, from here to here there is a one cycle, because after that there is a repetition of the waveform. So one cycle, in this one cycle, here is the T on, here is the T off. So this much duration of the time we are turning on the switch, and this much duration of the time we are turning off the switch. So now suppose that we are operating, if this converter, if the switch is operating at a frequency of 1 kilohertz. If the 1 kilohertz means what? Time period equals to what? 1 by f. If you will convert this time period equals to 1 by f, so time period will be what? 1 millisecond. So now the whole time period is what? 1 millisecond. If I am considering what? If I am considering 1 kilohertz. Now if I am considering the 1 kilohertz means what? The time period will be 1 millisecond. So obviously this whole time period will be what? 1 millisecond. 1 millisecond. So if it is a 1 millisecond and we are turning it on for a 0.5 millisecond. Okay. So now time period is what? 1 millisecond. We are turning it on for what? 0.5 millisecond. And we are turning it off for what? 0.5 millisecond. 0.5 millisecond. So whole time period will be what? T on plus T off. T on plus T off. So if we will combine this T on plus T off, we will get the total time period. Okay. So now we know that output is what? Output is nothing but the area upon time period, because it is now there is a what? There is some area is over there. So the area by time period, you will get what? Average output voltage. So if we want a V output, what is the, because this is the constant waveform with respect to the time, there is no change in the output waveform. But here we are, by the help of the switch, what we are doing? We are just T on, we are making the switch on and off. So V output is equals to what? This voltage will be what? Peak voltage 10 volt. So 10 volt into, for how much duration this waveform has appeared? This is for the 0.5. So this is T on by T. You will get the desired output voltage. How much output voltage you will get at the load side? So 10 into 0.5 millisecond by what? Whole time period is what? You can see that at T on plus T off there is a 1 millisecond. So 1 millisecond, so millisecond it cancel out. So at the output you are getting the 5 volt. So overall I just want to give an introduction about the how we are going to convert this 10 volt to the 5 volt by the help of this power electronic switch. As I have told you, the switch may be a MOSFET, maybe a IGBT, maybe any power electronic devices, maybe any power electronic device such as MOSFET. You can use IGBT or SCR, GTO, etc. Okay. So it is just about the introduction of the chopper. Now let's move on to the ideal step down chopper. So ideal step down chopper. Ideal step down chopper. Ideal step down. So let's make the circuit diagram. you also make a circuit diagram as I am drawing it. You also open your notebook and you just draw it in your notebook. And if you have any problem related to this lecture, or if you are not able to understand, you just comment me in the comment box. I will sort out your problem. Okay. Yes, this is IS, this is plus minus V SW switch, this is R, this is I0. I hope you all are familiar with all the power electronic switches. Okay, that's why I'm not discussing it over here. If you are facing any problem related to the power electronic switches, then I will make another lecture related to that. Okay. IT. Plus minus VT. So now you see this is the figure number 1, figure number 2, figure 3 and figure 4. You can see that in all figure looks same, only the thing is changed is over here is what? The switches, the arrangement of the switches. Means we are not here, we are using what? SCR. Here we are using what? GTO. Here we are using what? IGBT. So you can use any switches according to your requirement. As I have told you that each switch has its own benefit. Some switch has the higher switching frequency, some switch has what? Lower switching frequency, some has a higher voltage capability, some has a lower current rating or high reverse blocking voltage capability. According to that, according to our requirement, we will use that switch. Now, so there is no difference between any of the figure, only the difference is what I have made at this diagram. Only just I have changed the, here we are using, here I am using the SCR, here I am using the GTO and here I am using the IGBT. Now let's move on to the working mode. Now suppose that in the mode 1, what is happening? From 0, as I have told you, the switch has only two possibility. Either we can make a circuit or we can break a circuit. Means there will be a T on and T off, and whole combination of the T on plus T off will give you total time period. Now mode 1, when 0, between the 0 to T on, what is happening? Let's close the switch. You can take any one of the figure. IS is equals to IT equals to I0. This is plus minus V output. There is the voltage across the load. This is the I0. So when we are making this circuit, what is happening? What is happening in the circuit? If we will apply the KVL, what we are able to see? We are able to see that number 1 point is what? V output V output is equals to Vs. We are assuming the ideal switch. As I am assuming the ideal switch means there will be no drop across the switch. So there will be no time delay during the turn on. There is no time delay during the turn off. Okay. So instantly it will turn on at t equals to 0. Instantly it will turn off in the next half cycle. Okay. So what is happening during this mode? V output is going to be a Vs. This because same voltage will appear across this one, because there is a no drop over here, so this voltage will come parallelly across this load, so this voltage becomes this voltage. Okay. Second one, if the voltage is appeared across the load, so we can easily find out what average output voltage, that is the IO, that is the Vs by R simply. And as I am assuming the ideal switch, so voltage across the thyristor or voltage across any switch, the drop will be 0 volt. Okay. I hope you all are clear with this diagram. Let's move on to the mode 2. Now we are talking about from T on to T, means another half cycle. Okay, this is this T on and T off. So I have already talked about this reason. T on I have talked. Now I am talking about this reason. I am talking about this reason. This is the T off time. Okay, so here it is what? T on, here it is T. Okay. Now, so what will our circuit? Main circuit is over here. You can see that this is the main circuit. From here we have made what? From in the mode 1 we are turning on the switch, means we are closing the switch. So if this switch is closed, this voltage will appear across this one. Now we are opening the switch. So from this diagram we can make this circuit like this one. You see, when this switch is off, as we know that whenever the switch is off, there will be the zero current flowing in the circuit. If the zero current is flowing in the circuit, means what? There will be only the voltage will be blocked by this switch. So there will be no current flowing through this resistance or through this load. So there will be no voltage drop across this resistance. So if we will apply the KVL in this loop, what we are going to get? Minus Vs. You see, when you are applying the KVL now, I think I hope that you all are clear with the KCL and KVL, because this is the basics. This thing has already discussed in your first semester or in the second semester. I hope that it is the basic part which is discussed in the network theory also. Okay, so minus and plus. So we will move from here to here. You can write from here to here also. There will be no change in the equation. You will get the same result over here. You can use this and this polarity also. Okay, so now suppose that we are applying the Vs. So I am taking this polarity. It's your choice. If you want to take this polarity, you can take. Okay, so now minus Vs plus this terminal plus Vt. So plus Vt plus 0, because why? There is a no voltage drop across this one. If you need to write a voltage drop across this one, is what? Current into resistance. So the current becomes 0. So entire the drop will become 0. So this becomes 0. So Vt equals to what? Vt equals to Vs. Now we have got this equation, these three equations. We have got these three equations. When the switch is on, what is happening in the circuit, and when the switch is off, we are getting this equation. Okay, now let's draw the waveform of this circuit. What is happening? This is Vs, this is T. Okay, Vs is what? This is the supply voltage. This is the pure DC which we are applying to the converter. And as I have already discussed 2 to 3 page before that the waveform of the DC is like this one. Okay, now if we are applying the gate signal, so this is what? T on, this is T off, because there is a one control terminal over there. As suppose that this is the MOSFET, so this is the MOSFET, means what? There will be drain, there will be source, and there will be one controlling terminal. This is the gate controlling terminal. So here you have to fire. If you will fire through this gate terminal, then the current will flow from drain to source. Okay, so now suppose that we are applying the Ig over here. So if we are, when we are applying the Ig, so this is what? On period, this much duration of the time we are applying the Ig, and this much duration of the time we are applying, the switch becomes off. So this is off period and this is the on period for the switches. So if this is the on period and the off period of the switches, so again we have already familiar with that mode 1 and mode 2. When the switch is on, the output voltage becomes the input voltage. So if the output voltage becomes the input voltage, here you can see that the output voltage becomes the input voltage. So Vs is what? This is the input voltage. Okay, so we will get like this one. After that, again this is like this one. Again it will continue with the same time period for the T on and T off. So this is what? This is again Vs. This is the on period, this is the on period, T on period, this is the off period, this is what? This is I0, this is the output current. As we know that the value of the resistance, suppose that resistance is 2 or any if you are taking the numerical value only, there will be the change in what? Magnitude, because we are dividing with that. I0 is what? Nothing but the Vs by R. So if your magnitude is suppose that 5 volt, and if you are dividing by the constant, the magnitude will be less as compared to this Vs. Okay, so like this one, as it is a resistive law, it will also follow the same path, means same there will be no whatever the duration of the time for the T on is appearing over here, same there will be the T on period for the current also, because both are in phase, as we are using the